All right, so today we're going to talk about the fundamental counting principle and talk about permutations. Make sure you have your notes packet open and have out a calculator. The first example that we're going to talk about getting into this is, and this obviously will not be on the board right now, but if we were to just think about you all wanting to go to Subway and building your own sandwich, you were given an option to pick one bread choice, one meat choice, one cheese, one veggie, and one sauce. And so each person in the class would pick one option for each of these. So go ahead and take a minute and build your sandwich by choosing one option for each of these. Now you could take a second and compare your answers with the person next to you and see if how many options match up, if any. You can do the same thing with another person, so go ahead and pause the video and double check with everyone, and you can even check anyone at the same spot to see if anyone builds the exact same sandwich. So every single option is the exact same thing. And I think it would be very safe to say that it would probably be very unlikely that any two people had the exact same sandwich. And we're going to talk about why that is. So if you think about taking all of the options at a place like Subway, we're going to even streamline the menu just a little bit, but let's say that we have 7 total breading options. There are 9 different meat options, 6 different cheese, 7 veggie, 9 sauce. If you were to match everything but one with someone, they would still not have the same options, the same exact sandwich. So in order to find out the exact number of options, we're going to take all of these options and multiply them together. Now, while the variations are similar, but they are not exactly the same, there are a total of 23,814 different sandwich combinations using those limitations. And so we did that by taking all of the different variations and we were multiplying them. You can do this for any example. So the next one, if we are to think about doing some sort of a movie night, you and a group of friends are asked you to plan the trip, and you're going to see Beauty and the Beast, La La Land, and Power Rangers are all premiered. Your friends live around Lake Forest, so you guys are going to choose either the AMC in Vernon Hills, the Landmark, the Regal at Lincolnshire, or the AMC in Northbrook. And you also look at the theaters and you know that there are 2 showtimes after the time that you choose. Question is, how many different ways can you guys plan the evening if you guys were to think about all the different combinations? Well, there are 3 different movies you guys could choose. There are 4 different places you guys could go to. And there are 2 different showtimes that you guys could go see, which means there are 24 different options for you guys to go watch a movie on this particular night. So now, let's pretend we fast forward to college selection process or whatever. You've arrived on campus. They inform you that you need to log into your computer and you need to create a brand new password with specific requirements. And the leader of your group says that your password is going to be 6 spaces long and it must contain 4 letters and 2 numbers. If it goes in that order, 4 letters and 2 numbers, go ahead and write down any password. This could obviously change. But if the first 4 are letters and the last 2 are numbers, the likelihood of anyone in this class having the exact same password is very slim. Talk about how many different password combinations we have. If the first 4 are letters, and you are allowed to repeat the letters, then we could have 26 letters, different letters, A through Z, in all of the 4 spots. And if the last 2 are digits, using 0 through 9, so 1 through 9 plus 0, there are 10 different digits that we could use. And this gives us a total of 45 million. When you multiply this out, 697,600 different passwords. Now, using the same example, but if we said that you cannot have repetition. So you still have to use 4 different letters and 2 different numbers. So these are our letters and these are our numbers. But in this case, whatever letter you choose, you cannot repeat that. So there are 26 letters you could choose the first time, but once you take that letter out, there are only 25 letters left in the alphabet. Now 2 different letters are gone, so there's only 24 left and 23 left. And for the numbers, if you choose a digit the first time, there are 10 possible digits. Once you choose that digit, there are only 9 different digits left. And we get a slightly smaller number. Still 32 million combinations, 292,000. And so this is why when you guys are creating passwords, they have different variations of needing a capital letter, a number, a symbol, all of those different things, because all of those different restrictions make it a higher number. And the higher number of possibilities that you have for a password, or the longer it is, makes it less likely that someone would be able to steal your password. So a permutation is something where the order matters and it has a specific arrangement. The ordering of things. And so one example, how many ways can we arrange the letters of A, B, and C? If we selected A first, we could select A, then B, then C. Or we could still select A first, but then switch around C and B. There are also 2 different ways we could select with B first. We could go B, then A, then C. Or B, then C, then A. And then rearrange them with C going first. There's really 3 different letters we could put in the first spot. It could be A, B, or C. Once we take that letter away, there are only 2 different letters for the second spot and 1 letter for the last spot. So it is like the previous example, we're doing 3 times 2 times 1. Or another way to write that is 3, and that's called factorial. And what that means is take 3 and multiply it by each of the numbers that are less than it all the way down. So if there are 4 objects, you're going to go 4 times 3 times 2 times 1 with 4 factorial. 5 factorial would be 5 times 4 times 3 times 2 times 1, etc. So then some examples with that, if we were talking about an Olympic example, where in 2014 in Sochi we had 6 finalists qualified for the medal run in the freestyle. During the finals, the order of the skiers is not determined by their previous scores. It is instead entirely random. How many different orders could the finalists ski in the final competition? If there are 6 different skiers, then there are 6 different skiers who could go first. Once that skier is gone, there are 5 different skiers who could go second, 4 different skiers for third, 3, 2, 1, which is the same as 6 factorial. And we could multiply that out and find out that the skiers could compete in 720 different orders. And if you, when they do the award ceremony, they get the gold, the silver, and the bronze. So they award the top 3 places. How many different ways can those particular skiers, taking out the skill element of it just in it, before the scores come out, there are 6 different skiers who could finish first. There are 5. Once that skier is gone, there are only 5 skiers left for second. And then there are 4 skiers left for third. And since we stop at third place, we don't continue. So there are 120 different finishes, metal finishes. 6 different people could get the gold, leaving 5 for the silver, 4 for the bronze. And this above example with skiers is a permutation that involves taking a smaller group of items from a larger group. We took 6 total skiers from a group of 3 at a time. So this is notated as 6, P standing for the permutation, 3, which is equal to, just like we did 6 times 5 times 4. And that is written out as 6 times 5 times 4 times 3 times 2 times 1. And you'll see another example like this. All divided by 3 times 2 times 1. And what you see cancels. 3 times 2 times 1. 3 times 2 times 1. Leaving us with 6 times 5 times 4, which is the formula that you have next. N objects taken R times. And so suppose you've been sitting in a class not checking your phone. When you leave, you notice that you have received 6 Snapchats on your phone. And how many orders can you reply to the 4 Snapchats? To all 6 of them. So there are 2 separate problems. The first one, and how many orders can you reply to the 4 of them? So if you're replying to any 4, you only have time to choose 4. You're choosing from a group of 6, and you're only choosing 4 of them. That is, if you look up here, 6 factorial divided by, and then we subtract those 2, so 6 minus 4 is 2 factorial. Written out, 6, 5, 4, 3, 2, 1, and on the bottom, 2, 1. The 2 times 1 cancels on the top and the bottom, leaving us with 6 times 5 times 4 times 3. So there are 360 different ways you can respond to the order in which you can respond to 4. And if you want to reply to all 6 of them, then you're going to go all the way down. And we already did 6 factorial. And that would give us 720 different ways to respond to all 6 of them. The next page in the packet is your homework. Please use the notes in these examples to help fill these out. Thinking about how the order matters, just look at all of these, and then we will talk about this next time in class.